Unlike gases, the behavior of liquids and solids cannot be described by a set of laws. Um, since liquids and solids are composed of particles that are much closer together, a force of attraction exists between them, and we call them as intermolecular forces. And stronger these intermolecular forces are, higher the boiling point and the melting point of the compounds are. There are main three types of intermolecular forces. We're going to discuss it in this video. The first one is the London dispersion force, which is considered as the weakest interaction between the two molecules, and this exists between two nonpolar molecules. And remember, for example, CH4 here, this is CH4. Is this a nonpolar molecule? Yes. Why? Because carbon hydrogen electronegativity difference is less than 0.5. So if you have two methane molecules, what kind of intermolecular force is present between these two molecules? So that is London dispersion. So these two molecules are interacting with each other with the London dispersion force. Now this and all covalent compounds exhibit London dispersion forces. One more thing in this, that London dispersion forces are very weak interactions due to the momentary changes in the electron density in a molecule. So, but keep in the mind, it's very easy to identify. If your molecule is nonpolar, then between the two molecules will be the London dispersion force. The second one is dipole-dipole interaction. Now, if you look at, for example, this molecule, this is formaldehyde. This is a polar molecule. Why? Because carbon-oxygen electronegativity difference is more than 0.5. So there is a dipole. These electrons are more towards oxygen, and because of that, carbon has partial positive charge and oxygen has partial negative charge. So if you take another molecule, so I'm going to draw it like this, C double bond O. It's the same molecule. I'm just drawing it different way. Delta positive, delta negative. So if you look here, this is a dipole-dipole interaction. Negative is attracted towards this positive is attracted towards this negative. So dipole-dipole interactions are the attractive forces between the permanent dipoles of two polar molecules. Next is the hydrogen bonding, which is the strongest intermolecular force, and this occurs when a hydrogen atom bonded to oxygen, nitrogen or fluorine is attracted to an oxygen, nitrogen or fluorine atom in another molecule. Let's take the example here. This is very easy to identify. For example, look at water molecule. This is water molecule. We have hydrogens. In fact, we have two hydrogens that are attached to oxygen. So that means this hydrogen or these hydrogens can participate in the hydrogen bonding. So if you take another water molecule here, so this hydrogen can make a special type of bond with the oxygen of another water molecule, which is known as hydrogen bond. So, or this hydrogen can make a hydrogen bond with the oxygen of the another molecule. So if hydrogen bonding is present, then that's the strongest intermolecular force, and that results in higher melting or boiling points. So for example, let's say if the question is, I'll give you the formulas of the two compounds. One is HCl, another one is HF, and the question is, out of these two compounds, which one has stronger intermolecular forces present, and also which one has the higher boiling point. So think about what are the intermolecular force is present. Remember, London dispersion is present in all the covalent molecules. So we have London dispersion present in both. HCl, chlorine is more electronegative than hydrogen. So we have partial positive here, negative here. So if you take another HCl molecule, positive, negative, so positive is attracted towards this attracted towards this. So this is dipole-dipole interaction. Do we have dipole-dipole interaction in HF? Yes, because again electronegativity difference is more than 0.5, positive, negative, and we have, let's take another molecule, this, and positive, negative. So positive attracted towards negative, positive attracted towards negative. This is dipole-dipole. So this one has dipole-dipole too. Now what about the hydrogen bonding? Is hydrogen bonding present in HCl? No, because to show the hydrogen bonding, hydrogen needs to be attached to nitrogen, oxygen, or fluorine. Here it is attached to chlorine, so there is no hydrogen bonding in HCl. But let's look at HF. Hydrogen is attached to HF, to the fluorine. So if we take two HF molecules here, then this hydrogen can make a hydrogen bond with fluorine. This hydrogen can make a hydrogen bond with fluorine. So this one has hydrogen bonding also. So which one has more number of intermolecular forces? HF. Which one has the strongest intermolecular force present? HF. So HF is going to have the higher boiling point than HCl.
Made with Doodlecast Pro.